start recording. So now we start recording. Maher, I think I kind of differentiated between an increment and what a plus and equal to is. What I told you was it was addition, but it was actually not. So what the real meaning is, my dad just told me, uh, is basically when you add that variable to a number. So I'm going to share my screen real quick. So right here, the number also like switched it up for you because I feel like I said it wrong and my dad told me it. So it's basically a shortened way to add a variable to a variable. My dad reminded me, so I'm sorry for like saying that. And
Okay.
well, now
Okay.
that we got that, we're gonna start our slideshow. We're gonna go on to the next slide. So here's a trick to code your parameters. So PID is basically parameters, and we can basically change that into like a one line. So how we could do that is underneath our where we put our you see this where we put underneath DC motor we put this underneath that we could put PID coefficient since it's coefficients and test PID as like a new name, like as a name called test PID, which is equal to new PID coefficients, which is is equal to 0, I equal to 0, and D equals 0. And we can put that here, and then next we're gonna go scroll down, go to our PID, and rename it to test PID dot P, test PID dot I, and test PID dot D. What that does is it's basically simpling up because we don't have to go down and keep changing it, like scroll down and keep changing it. Basically, like a trick, so it's a shortcut basically, so you can just change it like right here instead, like change the numbers right here instead of changing the numbers here. So now here's PID in action. And this two, they're basically the same, but one of them has like they have a different line than the other. So let me first describe everything. Here we describe our motor. Underneath that is our basically what this is. I mean he I put this person the KPID here, but we could put underneath, but here is also fine. And we put, as I said before, how we had to describe our errors, last error and lines. We can put that underneath elapsed time and equal new elapsed time. Yeah, underneath our op mode, and we have to put our motors. We have to describe it as hardware maps, as I described last session. Then underneath wait for start, we have to put while op mode is active while our program is like running. Our power for the robot power is equal to PID control, as I discussed before. But we can actually put a reference. There's this line we can put reference as 1000. What that does is basically the amount of power it has. And we could put that as motor dot get velocity, the velocity of the robot, which is we could wait. So all right. So basically the velocity and the motor dot set power. Underneath that, we discussed about our public double PID control, and we have our double reference and state, which I found out an example. I don't for sure know the meaning of it, but I can tell you that the reference is about our previous examples, like the other like the times we tested out. But for state, I'm gonna let you know in the next session. So here, our double error equals to reference minus state, and then underneath that we put our integral sum, which is, as I said, plus adding a one plus and equal to, so adding a one variable there, as I said in I searched up on Google, my dad told me, which is error multiplied by our time. So how long did the time of how long it took multiplied our error. Underneath that we could put our double derivative, which is equal to our error minus our last error divided by our time it took. But here, what we added here, underneath our hardware map, we put our run without encoders. So in the previous session, I talked about that. What run without encoders is basically helps us like get the encoder ticks and actually run to the destinated position and to like this amount of ticks. So if we suppose our, so what I like to think of is our wheel, the robot wheel, into like and to cut it into half and stretch it out as a line. And each line we can cut into, make it into segments, and each line would be each segment would be a tick. So yeah, how many ticks it would take for one rotation. So now if you want to do 3,000 ticks, it would be, that would be the encoder count. And that's basically what I added in the example I added here. Now here would be our PID on our graph. So look, blue is basically what we want our robot to do. Our task is for our robot to go, I suppose, move right, go forward, move right, then come back and park. And red is our motor position, like what, like where the motor is, and the velocity, the amount, like so, or wait, so blue is the target position, or which is the velocity. Red is the motor position, which is the or divided by, or the velocity, not divided. And yellow is a motor command from PID control. So basically, what blue and orange is basically what we are controlling, and that's what we want to do. So you can notice how our graph over here, we want to focus here, is orange is kind of like, it's like there's a difference between our blue line and orange line, so we kind of want to make that similar, kind of like smaller, so there be less errors. Because right now there's an error here, but we want to like decrease that error. Here, there's also error here because we kind of want to decrease it, like kind of want to make it same right here. So here, this is how it works. So now, our line, so now we kind of change our PID, right? Once we change those numbers, kind of do trial and error on those numbers, our orange line can actually become into kind of like, there's more and more small numbers, more smaller numbers, which is our basically our double, double. So which is basically, you can notice how the error has between the red line and blue line has become smaller. Also, you can notice the yellow line we also control. It's kind of coming close to this line right here. The yellow lines are coming close here, and it's not really matching up in these two. So that's basically how. So look, basically on our IP address we got on robot, we can put slash, our like right slash, then type, and then dash type, and then you type dash. What that does is it opens you our, and you have to connect to the robot Wi-Fi. What that does is it opens to you your programming, but it basically shows you a graph for PID, which is really helps us out. It gives you a graph like this, but it's more like it describes you what P is, where P is, the numbers, and how it should match. And once you run it, like suppose you run the robots to go back and forward, it will keep the bars right here. It will keep on moving until it reaches the end. So that's basically it. Congrats, you kind of learned the basics of PID.
So, Vadud, I want to a little bit talk about that plot. Okay. So this is very nice plot. Okay. So just focus the blue line. Maybe you go back one more slide, Vadud. So focus the blue line. The blue line is the actual position the robot needs to be. All right. So that is what the target is. That's your goal the robot should do. The blue line. But what actually the robot is doing is the red line. It could be position, it could be velocity, it could be anything. Maybe you want to have some velocity or some position, which is blue. But what it's doing, suppose when the line starts, you see the blue is overshooting. Like, sorry, the red is overshooting. The red is going beyond blue. So actually, this is what is called as the oscillations that I mentioned earlier. It red is kind of, so now to bring that red back to blue, your controller is giving a negative yellow. See, the yellow line and the red line are opposite to each other. Means when the red is the max peak, yellow line same time is minimum. When maybe Vadud, you want to point that, point the red, which is the max peak, more up, yes. But the control you are giving to robot is the minimum, the yellow minimum point on the yellow. Minimum, yes. So you give so much opposite control because your goal is to bring back to the blue line. Then when you gave the so blue, next time the red came down, little bit down. You see, so move your cursor to the next peak down. Yes, red. So to correct that, you gave a yellow which is higher. Now the red became more close to blue, which is the next peak. Next peak. So red is your actual. Then you gave the blue, yeah, yellow, which is little down. So then this is called as the oscillations. So your yellow is the motor command. Those are the commands you are giving, and your whole goal is to tune your robot, which is actually doing like a red line close to the blue line after some time, basically. So did you follow? Again, the whole goal for this session is slides for you to get familiar. Once you have the laptop and the robot in front of you, you can code and see how the things are happening. So just I want you to visualize and know the different terminologies in these sessions, such that when you actually code, you know what's happening. Did you follow this thing? So I am not getting any answers. This means two things. Either you followed everything or you did not follow anything.
Yes, we did.
Yes.
Okay, awesome.
Also adding on to what my dad said, as you as you see the line moving, you can notice how the orange line and yellow line are kind of similar. So as my dad said, there's no peak at all. So it's basically kind of like staying on. They're basically parallel. So it kind of tells us how. Oh yeah, they actually correspond to each other. And you
Yeah,
can also
this is
see it here.
yeah, this is more nicer plot than the previous plot. And after some time, like red and blue meet, this means your robot is kind of, our whole goal is to of the PID tuning is to tune the robot as close to its actual position, basically. That's the whole goal. So after some time, you can see red and blue lines are together. So that's why you are not, your controller is zero. Controller command is zero. You're not doing any controller after some time. But initially, you started giving some changing the commands to get your red close to blue.
Anyways, moving on. Do you have anything to say? I guess not. So anyways, moving on, I guess congratulations, you kind of learned the basic of PID. You did not yet learn about the main things because like once you kind of program it, you kind of get the gist of it and kind of understand it'll be more like fun and better for you to actually sit in front of a laptop and actually program the robot and do it because it actually is kind of more complicated than this whole like slideshow. Sound like this is basically the basics. But once you go like dig deep, you will actually learn about there's different types of formulas involved, as I said, and it will go kind of involves calculus and all that. But anyways, I guess we kind of covered up like what PID is and how proportional integral derivative helps us in autonomous. Next session, we're gonna talk about how it can like help us in more depth for help us in autonomous and teleop for programming. So thank you for listening, and I'll take any questions.